The next property of carboxylic acids that we're going to look at is their acidity. Carboxylic acids are weak acids. And remember from the end of Gen Chem, you learned that that means that they exist in equilibrium with water. They will donate a hydrogen ion H plus to something that's acting as a base. So if you react a carboxylic acid with a strong base, because the strong base is controlling the reaction, you're going to get a total reaction. The carboxylic acids are completely deprotonated. And again, this is being driven by the strong base. The strong base is what's driving the 100% dissociation or deprotonation. So let's use acetic acid, and let's react it with a strong base like hydroxide, and it's going to be a forward reaction, and the hydroxide is going to grab hydrogen off of the OH group, and what we are left with is a deprotonated carboxylic acid and water, byproduct of that reaction. In water, carboxylic acids are in equilibrium, and their equilibrium strongly favors the left side. Which means that they are mostly unreacted. So let's draw same carboxylic acid with water. And this is going to be in equilibrium. Same type of reaction, a lone pair of electrons grabbing the hydrogen off of the carboxylic acid. We end up with the same anion, and our other product is hydronium H3O+. And we can use ARIO to help us understand the difference between these two reactions and to help us understand why with a strong base the reaction is favorable and it's all the way forward. And we can use ARIO to help us understand why this particular reaction exists in equilibrium. We're looking at things like, so if we go up to this reaction and we want to use ARIO, we would compare hydroxide to this acetate is what it's called. The first thing that we would look at is A, atom with the formal charge. It's oxygen for both of them. That's a tie. The next thing that we would look at is R, resonance. This guy has resonance where the other one does not, which makes this one more stable. So the reaction definitely favors the right-hand side. If we go down to our second reaction and we want to use ARIO again, so this time we would be comparing this molecule to this molecule. And the first thing that we look at is A, atom with the formal charge. This has no formal charge, so this one is more stable, and the position of equilibrium is definitely going to be favoring the left-hand side.